Well, there's currently no vaccine available that will prevent an HIV infection or a cure for those living with the disease. As you know, scientists have made huge advancements in treating it. The question remains, of course, as to whether a vaccine will come one day. Dr. Kathryn Mngadi is from the Aurum Institute. Dr. Mngadi, good evening to you, and thank you very much indeed for your time. We now know so much about the disease. We know so much about HIV. Is there still a lot more research we need to do to actually fully understand how it operates in the human body?
Good evening, and good evening to all the viewers. And yes, there's still a lot to learn about HIV. We do know a lot about it, enough to know what the challenges are to forming an HIV vaccine. So part of the challenges are that this virus has just unprecedented genetic diversity across the globe, within a continent, in a country, and even within chronically infected people. There is greater diversity of viruses in their body than there is for a flu, a pandemic in a year across the globe. And because of this genetic diversity, it's very difficult to have a vaccine that covers all of the genetic variants. Also, we don't have a single person that has cleared HIV infection on their own. So we don't have a human model to follow. And this makes it very difficult to formulate a vaccine that can cover all of the circulating variants.
This genetic diversity, does that mean it could actually be impossible to come up with one vaccine that works for HIV?
No, it's not impossible. There are certain areas of the viruses that are conserved or shared between all viruses. And so it's about incorporating the proteins from that section of the virus. And in fact, these proteins are genetically engineered in the laboratory. So we don't cleave any parts of the actual virus out to put in the vaccine. But building those genetic proteins are actually very difficult because they are notoriously unstable. But just recently, there has been quite a good advancement in actually forming those proteins. And there's a new study being conducted by IAVI in the US and in Kenya that is looking at evaluating this first genetic protein.
In the meantime, we have millions of people living on antiretroviral drugs. From what we know, they're ensuring that those people living with HIV are living the same life as everybody else. I mean, the advances around ARV drugs have been immense.
They have been absolutely amazing, the advances around antiretroviral drugs. But one challenge is adherence, because these drugs have to be taken for the rest of someone's lives. The drugs themselves have got very few side effects at the moment, but unfortunately, chronic infection with HIV does lead to complications in terms of development of non-communicable diseases, so heart problems, etc. So it's not that people have their lifespan considerably reduced, but they are more susceptible to some chronic diseases. So we really do need something that can help both the adherence and that can prevent infections, new infections in people who are uninfected at the moment.
Dr. Kathryn Mngadi, thank you, from the Aurum Institute.